Hello everyone. As you can see, I'm not very well today, so I'm not there, but I'm there in spirit, and this video is to make sure you're still working really hard. Recently we've been learning about photosynthesis, and this is of course photosynthesis. You've got 6 carbon dioxides. This reacts with 6 waters, as you know already, to produce glucose, C6H12O6, and 6 O2s. Of course, you need energy from the sun in the form of light to make this process go. When I say go, what I mean is it has a rate. And rate means kind of how fast something goes. So photosynthesis has a rate of reaction. So low rate means a low rate of photosynthesis. High rate means a high rate of photosynthesis. So it's pretty easy, really. So fundamentally, I've got some questions for you before we start. We're going to discuss things called limiting factors today, and I don't know if you can see, there we go, limiting factors on that screen, but a limiting factor is something that limits the rate of photosynthesis. I'll put it back on me now. So a limiting factor is something that limits the rate of photosynthesis. So what do you think? I'm going to go for Charmaine. What do you think is the ideal combination of factors for the maximum rate of photosynthesis? I'll pause. I'll give you a second to think. That's right, Charmaine. Well done. It is having enough light, having enough CO2, and the ideal temperature. Not too hot, not too cold. A combination of all these 3 factors, the optimum condition produces the optimum rate of photosynthesis. More questions. If you were to restrict one of these factors, what do you think would happen? I'll go for Sam, to the rate of photosynthesis. The teacher will need to pause the video here. That's right, Sam, well done. If you restrict one of these factors, then you'll affect the rate of photosynthesis. What I'm now going to do now is ask you some questions based on the 3 graphs that I've produced. Okay, and these 3 graphs are absolutely necessary to learn when you're learning about rates of photosynthesis. All right. So what I'm going to do is draw on these graphs for you, and you need to do this as well. So graph number 1 is discussing light intensity versus rate of photosynthesis. And I'm going to draw on this graph and ask you lots of questions. So that's my line. Okay. What I'm saying here is at this point, I'll call this number 1, as the amount of light increases, so does the rate of photosynthesis. So at number 1, you could argue, or you could definitely say, that light intensity is the limiting factor. So as the light is low, rate is low, and as the light intensity increases, the rate increases. The thing is here, you can see that past this point I've highlighted, the rate does not increase any further. So here, quite clearly, I'll label number 2, there's a limiting factor for the rate of photosynthesis. You could argue that here increasing the amount of light has no effect on the rate. So I'm going to ask, who shall I ask? Melissa. Melissa, what are the limiting factors associated with the area number 2 of this graph? Bearing in mind that light, CO2 and temperature are the 3 limiting factors for photosynthesis. Well done, Melissa. As always, very good. That's right. Here you could say the limiting factor is now carbon dioxide, or temperature? Because we're saying that light intensity has, as I increase light intensity, has no further effect on the rate. So something else must be affecting the rate. So my next question is, go to Chris Stoker. Chris, what must be increased for the rate to increase? That's right, Chris. Must be CO2 and temperature. Very good. Next bit, next graph. Rate versus concentration of CO2. So here, as the concentration of CO2 increases, the rate increases. At point number 1 of that graph, I can say that as the amount of carbon dioxide goes up, so does the rate. So the limiting factor is carbon dioxide. So watch. If I say the concentration of CO2 is low, the rate is low. When the concentration of CO2 is high, the rate is higher. But all of a sudden, at point number 2, as I increase the concentration of CO2, the rate of photosynthesis doesn't increase anymore. So, at this point, I'll go for Murph. What is the limiting factor? Well done, Murph, that's right. The limiting factor here, as you could say, would be the light or the temperature. Because it's no longer CO2, because clearly as I increase the concentration of CO2, the rate isn't being affected. So what must be increased, please? I'll go for Ethan. What must be increased for the rate to increase? That's right, Ethan. It can't be the concentration of CO2, so it must be the light or the temperature. And the last graph we have here is a very important graph, and it's not the same trend lines as the first two, concentration of CO2 and the light intensity. What you'll find here is this. This kind of thing happens. So what we're saying is that as the temperature increases, so point number 1, so does the rate, because photosynthesis enzymes work better in relatively warm conditions. So we'll say that's about 30. So the maxima, around about 30, we're saying the rate of photosynthesis is quite high. Here the limiting factor is temperature. So what I'm saying is that at point number 2, when it gets too hot, 45, the rate drops to 0. Why is this the case for, please? I'm going to go for, who should I go for? To make sure she's not fell asleep yet, Charmaine again. My question was, why is this rate of photosynthesis dropping so dramatically to 0 when it's at 45? The answer is correct. The enzymes have denatured. What that means is that the enzymes, they can't function well at 45. So the mechanism of photosynthesis, the enzymes that drive photosynthesis, they stop working. So the rate of photosynthesis drops to 0. Interesting, isn't it? So what is the limiting factor at point number 2 here? It's almost like a trick question. Anyone? Anyone? Okay, it's quite a hard question really, isn't it? I'm going to go for Dylan. No. Matthew? Okay, no one knows. Or maybe you do. Maybe I'm just presuming too much. Well, the limiting factor is temperature. Because clearly at this point, nothing else is limiting because the enzymes have been destroyed or been denatured by the rapid increase in temperature. So temperature, in effect, is the limiting factor number 2. What do you think? That's what I call cover work, that is, isn't it? Huh? Yes. Anyway, we'll keep going. So your work now is to produce, a concept map. And the concept map, I've got it on my computer. Hopefully you can see this. Maybe you have to pause the video. It's going to look like this. Okay? So you're going to draw every single one of these words and concepts onto a single page of your book and link all of the concepts and words together with lines. And on the lines, you will have meanings and definitions and why you've linked these lines to each other. And the two teachers in the room will come around and give you a hand. I will check this work next lesson. If you haven't done it, I'll find you and I'll call you on it. And I'll say, why has it not been done? I wasn't here, but it doesn't mean you didn't work. So, end of the day, do a great job as you always do. Don't forget, 36 weeks until your final exams. Peace out, little ones. Au revoir for now.